Looking at problem 6 now. So in this case, how many protons are present? So P we know is 12, and the number of electrons is 10. So we're going to have 2 more plus charges than we have negative charges. But it is the proton number that identifies that metal. So let's go back to our periodic table. Take a look at it. Whoops, wrong thing here. So we're looking for P12, number of protons. There it is. That identifies this as magnesium. And it has 2 more plus charges, so it must be Mg2 plus, not just Mg neutral. And that's because of the difference in the protons and the electrons. Here's number 7. Now to do this, we're going to have to do a little bit of arithmetic, or algebra even. So remember that we have a mixture of isotopes, and in this case it is that fraction times the gallium-69, so that's 68.926 AMUs, added to the fraction that is the other gallium, and it's since the average here, so our overall average mass turns out to be 69.723 AMUs. So because this is bigger, I'm going to assume that's gallium-69. We don't know what that is, but we'll assume that that's what it is. And the question is, what is the AMU of this? Well, what do we know? We know that F1 of the gallium-69, we'll say, I'm sorry, I called that 69, but it's got to be 70. This is 60.111%. And F1 plus F2 must equal 1. So we're going to take 1 minus 60111 equals the second fraction. So let me do that arithmetic. And that turns out to be then, my pen keeps stopping working, so that F2 is equal to 0.39889. So we write this out then in long form, so it's going to be 0.60111 times 68.926 plus now 0.39889 times our unknown. So we're going to call that now X. That's our mass. And that's going to be equal to 69.723. And then we're just going to solve this. So let me clean this up a little bit. Okay, so I've actually done all the arithmetic here. And so here's the steps. I just took this. So my fraction that I was given, subtracted from 1, gives me the fraction of the other isotope. Add those together to give the weighted average, which is this answer over here. I then multiplied through to get 41.432 AMUs plus this thing is equal to 69.723. I then have to get the X on one side by itself, so I subtracted 41.432 from both sides, and then simply divided by this on both sides to come out with my answer here, which is 70.924, and that would be the correct answer then. So moving on to problem 8. So now we are given, again, this is supposed to be 40 isotopic notation, X and 18. And determine the number of protons, neutrons, and electrons. So protons are always the atomic number, so that's 18. It is a neutral, and so the electrons are going to be 18. So let's look at our answers. There we've got 18, 18, 18. One of those three can't be either the top two. And then the electrons are 18, 22, and 40. Well, it has to have 18 electrons because it's neutral. So that means the only possibility is this choice here by process of elimination. So let's just double check to make sure there are indeed 22 neutrons. So if we add 22 to 18, we get 040, and indeed that's the mass number. So that's our answer for this one. So moving to Chapter 9, we now have it's a calculation problem. And what are we given in this particular problem? We are given 398, and it's milligrams of krypton. And what we want in our answer here are moles of krypton. So we're going to go to our base unit, go to grams, and then we can make our conversion into moles. So 398 milligrams of krypton. We're going to cancel milligrams krypton. That has to go down there. And we want to make that grams of krypton. And which one's the big one? Grams. And there are 1,000 of these little ones. So now we need to cancel grams of krypton and convert that into moles. And that's the atomic mass. So I'm going to have to pull out the periodic table. And for krypton, that's over here. And that's 83.798. So 83.798. Sorry for my chicken scratching as they were described. And then I do the arithmetic. So then when I do that arithmetic, what this turns out to be is that's equal to 0.00475, and that's moles, because those grams canceled, or 4.75 times 10 to the minus. So then that brings us to number 10, question 10. Again, same thing. What are we given? What do we want? And we are given 158 kilograms. And I'll write that as 158 times 10 to the third grams, and that's a phosphorus. And we want to know number of atoms. Now we can't go directly from grams to the number of atoms, so we go through the mole, and then we go to the number of atoms. So 158 times 10 to the third grams phosphorus. We're going to cancel grams phosphorus, so it goes down below. Moles phosphorus up above. We can cancel those units. Then we can cancel moles phosphorus and go to number of atoms. And that's always 6.022 times 10 to the 23rd for every 1 mole. And then we have to look up grams per mole of phosphorus. So we do that. We find phosphorus is in here somewhere. So how do I just move that? So phosphorus is 30.974, 30.974 for 1. And then when I do that, my answer comes out to be 3.07 times 10 to the 27th atoms of phosphorus, right? So there we go, right there. And that's it for problem 10.